There comes a time in every student's life where they have to present a project for Mr. Meneses, their pre-calc teacher, and then turn it in a week late. It happens to everyone. It's a normal experience, probably happened to you. So, without further ado, here's my presentation of the unit circle. Definitely on time. Firstly, I wish to show you the project that I created with so much hard work. As you can see, it contains the unit circle, an explanation of what the unit circle is in a fun and creative way, how to learn it, and the other juices. Besides, we also have something called Unit City, where you are being welcomed kindly by all of the parts of the unit circle. Here you can see a bunch of fun stuff, like a degree doing a backflip. I have here on my left the definition that I creatively invented about the unit circle. So I like to define the unit circle as the superhero of circles. It's a way for us to quickly solve trigonometry problems because it contains the sine and cosines and tangents of every single angle that there is in a circle. So, it's pretty awesome. It is split on an X and Y axis, and then several other intermediate angles between, and so here we have all the coordinates placed neatly and correctly all on the circle, and then we have our radians also neatly and correctly placed. The best way to learn this, and the quickest way to learn this, is to start from 0 and move in increasing numbers from 30, 15, 15, 30, and then back again, 30, 15, 15, 30, all the way around the circle until you get back to 360. I like to split the unit circle into two parts of 180 and 180. So then there's a kind of systematic increase and then decrease back down after 180 degrees. And so the denominator of any given radian will always start off in 1, and then it will progressively go from every time you click to one other line, I like to say click, you go up to 6, then 4, then 3, and then in the middle, at the 90 degrees, we have 2, and then back successively the other way around. So then we start with 3, and then we go to 4, and the 6, and then we go back to 1. And that just repeats itself this way and all the way back. And then filling the numerator is just common sense. Similarly to the radians, the coordinates also follow a certain pattern that goes successively up and stops in the middle on the top and then goes back down. And so the way it is that we start with the coordinates 1, 0, or vice versa, whichever, it doesn't matter. And so then we start going up in this progressive way where the first one is always going to start with square root of 3 over 2, and then the second, comma, 1/2. And then the next one's going to be, and this one will always be in the ones that resemble the 45-degree angle, it's going to be square root of 2 over 2, comma, square root of 2 over 2. And then we'll have the opposite of the first one. So instead of having the 1/2 last, we put it up in the first, and the square root of 3 over here, and we put the comma, obviously. And then we go back to 1. But in this case, depending on where we are on the plane, we'll put the 1 on either the x or the y side, and then adjust for the rest of the circle in any other part of the coordinates. Adjust them the signs according to whatever quadrant it's in. And the unit circle is not only useful for trigonometry, it's also useful, for example, in navigation, where you can help calculate the coordinates that there are between two different points, or in engineering, where engineers use the information that they get from the unit circle about angles to create strong and long-lasting structures. In physics, it helps them calculate wavelengths and wave barriers in different objects. And in the computer graphics, it helps graphics artists in video games, for example, to create convincing 3D graphics.